Okay, so this is going to be the quest on 257, example 7.8, the one sample test for proportion. And let me just do a little snip of that screen and remove the previous one. Okay, so what we're doing here, and actually just let me go back to the spreadsheet, is we have this was the test for proportion. It's available from kind of the spreadsheet, the hypothesis spreadsheets, but I've also got it available on my spreadsheet for this week. And we're just going to be putting in the numbers for this specific example. So the test for proportion, we have a few little things. So let me go back to the right thing I wanted. And let me just choose a black pen. So we have our hypothesis, which is on a proportion. So we have a hypothesis on a proportion. Now here we have some customer service example. And we have 4 categories of customer service. And we want to see, we have a standard that, 75% should be in the top 2 categories. We want to check whether this is like greater than 75%. So our first little one-tailed is going to be the null hypothesis. It's not greater than 75%, and the alternative hypothesis is it is greater than 75%. So that's the one-tailed test. And of course, we won't maybe see if it was less than 75%, so we could also have in the other direction H1, and we could be testing that it's less than 75%. We could also have a two-tailed version. And here the two-tailed is and the alternative hypothesis. So we just check saying, hey, it's not going to be equal to 0.75. And to do that, basically, we're seeing how far away our sample is. So our sample, we define something called p hat. So p hat, and this is going to be equal to x, which is our number of successes, all over n, which is our total number of runs or total number of experimental runs. And here we're being told that this is going to be 35 of the 40. We had 44 responses, and 35 are going to be in these top 2 categories, which was 0.795. And we could actually put that in the spreadsheet. And then the book tells you, hey, we have our z, and the z is basically the proportion minus our hypothesized proportion all over the square root of our hypothesized proportion. And again, for the exam, this really isn't a stats class, so I'm not going to ask you to do any of the hand calculations divided by n. So that then we calculate the z value, and then if the z value is out of the critical region, so in the critical region, then we reject. So Again, the further away our actual p hat is away from our hypothesized value, the more likely we are to reject. And this leads to a bigger value of the z, or a bigger magnitude for the z test. Okay, so we're back on this where we're testing the hypothesis. So the sample size of 44. Let's just say you want to use it for your homework. We put in the n here, the sample size, and the proportion of successes. So in this case, in the example on page 257, this is 35 divided by 44. And we get it to a slightly actually more accuracy here. We're hypothesizing that it's 0.75. And we're just going to stick this. We usually use 0.05. 0.01, what you see, would give us a stricter test with higher z-scores we need to get past. Say 0.1 would give us a less strict test, but let's stick with 0.05. See, the z statistic is as per the book on page 257. We also have, this is our rejection region. So we have our type 1 error of alpha 0.05. This is, the area that this kind of type 1 error lies outside of. So we need to get bigger than 1.64 for a one-tailed test. An upper one-tailed test, it would be greater than this value. Lower one-tailed test, it would be less than the negative this value. Two-tailed test, we reject if it's less than minus 1.96 or greater than plus 1.96. So let's just check. We are doing an upper test as per page 257. Our critical z is 1.645. Our actual z is 0.696. So our actual z is less than the critical z, so we fail to reject. Again, the easy way of doing it for all tests, the p-value is greater than my alpha, my level of significance. So again, we fail to reject on that. And if we're going to fail to reject for the one-tail, we're going to fail to reject for the two-tail. Because if 0.696 is less than 1.645, then it's obviously going to be less than 1.96. And our p-value for the two-tailed test is double the p-value for the one-tailed test. So again, we do not reject. So the results of this, let's go back to our screen. Let's use a red pen. Let's try and be consistent across tests. So we don't have any evidence here. So the one-tailed test, our proportion was a little bit over 0.75, but it was not significantly over. So we'll put a little cross there, and we'll put fail to reject H0. And the two tails, again, we'll put a little cross, and we'll put fail to reject H0. And so we've not got enough evidence that this value here is far enough away from 0.75 to say, hey, the population value is definitely greater than 0.75. It's a little bit more, but it's not a lot more. Now let's just see, for example, let's just play around with our template. Imagine out of 44, 40 were in the top two service categories, and our proportion was 0.9. You see now that our z statistic is 2.43. It's greater than 1.65. It's greater than 1.96. So in that case, we would say, yes, we're going to reject H0 in favor of H1 in both the one-tailed and the two-tailed versions. So let's just actually put it back. And there we go. That's just our one-tailed proportion.